Now we'll see how to derive the spherical harmonics YLM, which is used to construct the wave functions I and LM. Here I have derived for L is equal to 0, 1 and 2. So M is for L is equal to 0, M is 0, and L is equal to 1, M is minus 1, 0 and plus 1, and L is equal to 2, it is M is plus 2, plus 1, 0 and 1, minus 1 and minus 2. So if you take a wave function psi n l m, it is in terms of r, theta and phi. So here it is divided into two parts. One is in terms of r and another one is in terms of theta and phi. So if it is the function of r, it is r n l of r and y lm of theta and phi. So here this r n l m of r is a radial part and y lm is a theta and phi. It is called as spherical harmonics. So in the previous video here I have provided the link. So in that here how to derive the radial wave function, it is mentioned in this YouTube. Now I have present the spherical how to derive the spherical harmonics. So spherical harmonics YLM of theta and phi is equal to square root of 2L plus 1 L minus M factorial divided by 4 pi L plus M factorial into e power im phi PLM of cos theta. And PLM of x has the derivation as PLM of x is minus 1 whole power m 1 minus x squared power m by 2 d by dx whole power m PL of x. And PL of x can be written as 1 by 2L L factorial d by dx power L x squared minus 1 power L. So here it is PLM is associated Legendre function and PL of x is the Lth Legendre polynomial defined by the Roderick formula. So here in some cases, that is if L is more than 1, you have M is also has plus 1 and minus 1, plus and minus. So here the minus value, that PL of minus M is equal to minus 1 whole power M L minus M factorial divided by L plus M factorial PLM of M. So if you substitute this value, you can find Y L power minus M of theta and phi as. So if you take YLM of theta and phi, in that you substitute, instead of M you substitute minus M, then you can get this equation. So in this you substitute PL of minus M cos theta as from this function. So it is YL of minus M theta and phi is equal to square root of 2L plus 1 L plus M factorial divided by 4 pi L minus M factorial and e power minus im phi minus 1 whole power m and substitute that PLM of minus. Okay. So here after deriving all this we can get YL of minus m theta and phi is equal to minus 1 whole power m YL of L of m theta and phi and complex conjugate. So if you find this YL of m theta and phi, then we can find out YL of minus m. Okay. So similarly, if you know the value of PL of m, then you can derive PL of minus m. So using this. So first you take L is equal to 0. So if you take L is equal to 0, m is equal to 0. So in the P L of x, so in this equation you substitute L is equal to 0, then you can get P0 of x is equal to 1. And similarly, PL of m, that is if you substitute L is equal to 0 and m is equal to 0 in this equation, we can get P0 of 0 of x is equal to 1. Okay. So YLM of this theta and phi, here also you substitute L is equal to 0 and m is equal to 0. You end up with Y0, 0, theta and phi is equal to 1 by square root of 1 by 4 pi. So now you take L is equal to 1. Suppose if you take L is equal to 1, you have M is minus 1, 0 and plus 1. So if you take, first you take M is equal to 0. So M is equal to 0, L is equal to 1. So P L of X, it is only depends on L. So L is equal to 1, then you can get P1 of X is equal to X. And here generally it is in terms of cos theta, so it is P1 of cos theta is equal to cos theta. And PL of X, that is L is equal to 1 and M is equal to 0, you are going to end up with P1 of 0 of X is equal to X. So it is P1 of 0 cos theta is equal to cos theta. So similarly, you substitute this value in YLM, then you can get Y10 of theta and phi is equal to square root of 3 by 4 pi into cos theta. Next is with L is equal to 1 and M is equal to 1. So the P1 of X, PL of X is only depends upon L. So it is, we can take it with the P1 of X, and P1 of 1 X is equal to this minus of 1 minus X squared whole power 1 by 2. So if you substitute this, instead of X you substitute cos theta, then P1 of 1 cos theta is equal to minus sin theta. So so we are getting YLM of theta and phi for this case is minus of square root of 3 by 8 pi e power I phi sin theta. And if you substitute the value for minus 1, M is equal to minus 1, you can get it is plus e square root of 3 by 8 pi e power minus I phi sin theta. So next is for L is equal to 2 and M is 2, 1, 0, minus 1 and minus 2. So first case you take with L is equal to 2 and M is equal to 0. So it is that is P2 of X is equal to, we are getting it is P2 of X is 1 by 2 X squared minus 1 plus 2X squared. So it is P2 of cos theta is 1 by 2, 3 cos squared theta minus 1. And here PLM, that is P2 of 0 of X is equal to P2 of X. So it is P2 of 0 is nothing but it is 1 by 2, 3 cos squared theta minus 1. So if you substitute this value in YLM, then it is Y2 of 0 is equal to 5 divided square root of 5 divided by 16 pi into 3 cos squared theta minus 1. So next is for M is equal to 1, L is equal to 2. Then the P2 of X is the same thing, and PLM is P2 of 1 is equal to of cos theta is, if you substitute the value of M is equal to 1, then you are end up with minus 3 cos sin theta cos theta. So if you substitute this value in YLM, that is Y21 of theta and phi is equal to minus of square root of 15 divided by 8 by e power I phi sin theta cos theta. Similarly, if you do it for M is equal to 2, P2 of cos theta is the same thing, that is 1 by 2, 3 cos square theta minus, and P2 of 2 is minus 3 sin square theta. So it is Y2 of 2 theta and phi is minus of 15 divided by 32 pi e power I 2 phi sin square theta. And in terms of y in minus, then it is, we have this formula. So substitute this, then we are end up with y2 of minus 1 theta and phi is square root of 15 divided by 8 pi e power minus I phi sin theta cos theta. Similarly, for y2 of minus 2 is square root of 15 divided by 32 pi e power minus I 2 phi sine square theta. Thank you.